Hey, what's up everyone? Today we're going to be talking about vectors. Let's get started. For many students, this is the first time learning about vectors. And if you're confused, it might sound trivial, but just think of vectors as an array of arrows. You got long arrows, short arrows, pointing in every direction. Note that each arrow, or vector, has both a direction and a length. For vectors, we use these two notations. The x component determines how far the arrow goes in the x direction. The y component does so in the y direction, and the same for the z direction. A neat property of vectors is that you can move the arrow around and it does not affect the direction or the length. So I can move this arrow here. Let's do an example. Let's construct a vector a equals 2, -1, 3, and put another vector b equals 1, 2, 0, and place it on the head of the a vector. What is this new vector? This introduces vector addition. To do this, we simply add each component with each other. In the x, we get 2 plus 1, in the y, we get -1 plus 2, and in the z, we get 3 plus 0. And altogether, our new vector a plus b equals 3, 1, 3. We now assign this new vector as the c vector. Now another question. Consider the c vector. What if we want to increase the length but keep its direction? This introduces another property, scalar multiplication. We can multiply any constant to the vector, and we can distribute it among the components. This keeps the same direction yet increases the length. For example, if we multiply our c vector with 2, what happens? Well, we distribute the 2 to each coordinate and we ultimately get 6, 2, 6, which we will now assign as the d vector. With all this talk about increasing and decreasing length, you may be wondering, how do we even calculate the length of a vector? Well, the answer is pretty simple. The answer is the square root of each component squared summed all together. And see that this comes directly from the Pythagorean theorem. For example, the length of our d vector is the square root of 6 squared plus 2 squared plus 6 squared, which all equals the square root of 78. Now that we know about length of vectors, let's introduce a very special vector, the unit vector. This is the vector of length 1. Now here's another question. Let's say that we have our d vector. How do we find the unit vector in the direction of this d vector? Well, to find the unit vector in this direction, you multiply each component with 1 over its length. This is possible because of scalar multiplication. For the d vector, we already know that the length is the square root of 78. So the unit vector is 6 over the square root of 78, 2 over the square root of 78, 6 over the square root of 78. And if you double check your work, you will see that the length of this new vector will be 1. For review, to add vectors, add each component with each other to get our new vector. To multiply a scalar with a vector, just distribute the scalar among the components. To find the length of a vector, use the equation the square root of each component squared summed all together. And to find the unit vector, i.e. the vector of length 1 in the direction of a, just do a over its length. Here is an example that you can do on your own. Click here for the answer. And remember everyone, understanding the concepts is only half the battle. Make sure you do plenty of practice to really hone these skills and master the material. Thanks for watching.